All right, welcome to 6.2 Solving Systems by Substitution. In 6.1, we solved systems by graphing, and we were able to pull the solution, or ordered pair, from the graph. Now we're going to use algebra and solve systems by using the substitution method. So please go ahead and complete the target. The warm-up problem is to isolate each equation for either y or x. So let's look at number 1. To isolate for y, we're going to have to move the 2x. So let's subtract 2x from both sides. And we have y equals, to keep it into slope-intercept form, we can sneak the negative 2x in front. And there's our equation rearranged. You'll be doing this at times throughout solving substitution, or solving systems using substitution. Number 2 is a little more involved. So let's make the Great Wall of Math. Again, we're solving for y. So let's get rid of our negative 6x. You can do a 2 pencil mark trick if you'd like. To move negative 6x, let's add 6x. And we're left with 3y equals 6x plus 12. And to get y completely by itself, we'll divide everything by 3 and get y equals 2x plus 4. Okay, so we have numbers 1 and 2 done. So we have equations solving for y, and we put them in slope-intercept form. Now, there are going to be times when we want to isolate the variable and solve for x. So let's look at number 3. To get x by itself, I have to look at that 3. How am I going to remove that 3 from the right side? I'll subtract it. And so I have y minus 3 equals x. So x is now isolated. And for number 4, I want to get x by itself. So let's remove the 3y by subtracting. And I now have 2x equals, I can say negative 3y plus 4. And I need to isolate x, so I'll divide everything by 2. And I get x equals negative 3 over 2y plus 2. Again, there are times when it's best to isolate for y or isolate for x. We'll definitely have to do that when we solve for using the substitution method. All right, so why should we solve using substitution? In section 6.1, we solved systems using graphs. And now there were times when we got an exact solution from a coordinate plane, but there were other times, more specifically in word problems, where we had to estimate solutions from our graphs. And there's always a little bit of human error when you graph. So using substitution or using algebra will give us the exact answer. So we've got 6 steps here. We're going to look at step number 1, solve for either x or y in one equation. We only need to do one equation, so circle that or highlight that. All right, then we need to substitute the circled half of the other equation. Substitute the circled half of the equation into the other equation. All right, and solve. Let's stop there and go ahead through our example problem. Okay, right here, this system. So we take a look, we have y equals 3x and the equation y equals x minus 2. There are times when we have to do step 1 and times when we don't. So solve for either x or y in one equation. Well, look here. Y is isolated in both my equations, so that's even better. Now, step 2, substitute the circled half of the equation into the other equation. All right, so let's take a look at 3x. Y is equal to 3x. So another way I can describe y is I can say 3x. They're equal. We know that this equals symbol means that the left side is equal to the right side. So anywhere I see this y, a y in my second equation, I can substitute 3x. Just like a substitute comes in for a teacher. Teacher is out sick, a substitute fills in. So I'm going to substitute, instead of writing this y, I'm going to substitute that 3x equals x minus 2. All right, so that's step number 2, to actually substitute. Now I have my Great Wall of Math, and I need to solve for x. The reason we substitute, because if you look at this line of the equation, we no longer have a y. We only have x's. When there's one unknown variable, we can solve for that value. So let's go ahead and algebraically move this x to the other side. That gets eliminated or made zero paired. -2 on the right, and then we have 2x. One-step equation to solve for x, we're going to divide by 2, and I now have x equals -1. Now let's go back to our steps. We're looking at step 4. Substitute your answer from step 3, which is right here, into one of the original equations. I say typed equation, meaning because if we made a mistake when rearranging, if we did rearrange, then the mistake would be caught. So if I want to, I could do either equation. It doesn't matter. I'll show you both of them just so you can see, but really you can just pick one. So if I resubstitute y is equal to 3x, instead of writing x, I'm going to write -1. So y is equal to 3 times -1. 3 times -1 is -3. Let's check the other equation just to show. So y is equal to x minus 2. Y is equal to, I'm going to put in -1 for x minus 2. And y is equal to -3. Again, you don't have to do both. I'm just showing you both. There are times when there's an easier equation to substitute back into, and times when it really doesn't matter. All right, so we did step 5. We solved for the other variable. Now we're going to write our answer as an ordered pair. So the solution is what your x value is and what your y value is. So as an ordered pair, -1, -3 is my solution. And if I ask you, well, what should happen on a graph at that point? Hopefully you would tell me the lines would cross. Let's go check on the first 2 lines are right here. And there is your solution, -1, -3. It's always a great idea to check on Desmos. All right, so the first example, number 1. So step 1, okay, let's see if I can keep these steps available for us to see. Step 1 is to solve for either x or y. Do I have a variable isolated in one of my equations? I do. So I'm going to circle what it's equal to. So y is equal to x plus 1. Remember, that means anywhere I see y in my second equation, instead of writing y, I can substitute. And I'm going to substitute this entire expression. All right, so I have 4x plus, I'm not going to write y anymore. I'm going to write x plus 1 equals 6. Now let's solve the new equation. Combine like terms. 5x plus 1 equals 6. A lot of this can be done mentally. 5x equals 5. And to undo the multiplication, I divide, so x equals 1. Now for this equation, right, to go find my other variable, which happens to be my y, I'm going to substitute my answer from step 3 into one of the original typed equations. Can you see that the top equation is most likely easier? Y equals x plus 1, but I'm going to substitute the value. I got 1 plus 1. That seems a lot easier than using that second equation. So I have a value for y is 2. All right, and then step 6, write your answer as an ordered pair, 1, 2. Be very careful that you write the values in the correct coordinates. There are going to be times when we solve for our y value first and then go back and solve for our x. So just be aware that you do write your correct x and y's. All right, so again, these 2 equations should cross at the point 1, 2. Let's check it out. 1, 2, right there. That's my solution. Let's go to example 2. Hopefully you guys are getting these steps and seeing. So number one, is the equation isolated for, or one of the equations have a variable isolated? Well, I'm lucky that I actually have both of them in this case. I have two equations with a y isolated. So I'm going to circle the top equation. Y is equal to x plus 3. So when I rewrite this equation, I'm not going to write that y. I'm going to write x plus 3 equals 2x plus 5. Variables on both sides. My suggestion to you is to look at the variable with the smaller look at the term with the variable of the smallest coefficient. So we can put that 1 there. I'm going to compare 1 and 2. I'm going to move the variable with a smaller coefficient, just so I don't have negatives. So I'm going to subtract 1x. And because these are my like terms, the 2x and the negative x, I'm writing that minus 1x right underneath the 2x. So I have x plus 5 left over. And then if I subtract 5 from both sides, I have x equals negative 2. So again, in this case, I did get the x value first. I can go substitute into either of my equations. This one, I would do the first one again. Seems a little easier. So y plus 3x, y equals x plus 3. Let's substitute negative 2 in for x. And hopefully we get the value of 1 for y. My last step is to write it as an ordered pair. My y goes in my y coordinate, and then my negative 2 in my x coordinate. All right, let's check to see this one. I have all these equations pre-typed. So I can see the solution, negative 2, 1. All right, the next equation. I actually have a variable already isolated, and this time it happens to be x. That's fine. That expression is equivalent to x. 2y minus 4 is equal to x. So now, instead of writing this x in this equation, I'm going to write this expression. So let's substitute 2y minus 4 for x plus 8y. You see, I'm just completing that equation, equals 16. All right, so I can add like terms on the same side. 2y plus 8y is 10y minus 4 equals 16. This is a negative 4. If you'd like to do the 2 pencil mark trick, you can. To make a 0 pair, we add 4. And we have 10y equals 20. Almost there, divide by 10, y equals 2. Now I'll go back up and resubstitute my value for y into one of my equations. I'm going to use the first one since it's already ready to be set up to solve for x. So I have x equals 2 times 2 minus 4. X equals 4 minus 4. So therefore x equals 0. This is one where you need to be very careful. You finally solve for your x, that's a 0, and your y value is 2. Be very careful, again, writing your ordered pair. Let's check these two. And I should have 0, 2 as my solution. All right, at number 4, we have 3 more like this and 2 more word problems. Number 4. Now this is where we need to, when we substitute, I'll take note to tell you about when we use parentheses. We go through those same steps. Do we have a variable isolated? We do. We have y. We don't have to rearrange anything. Now we can circle that x minus 4. And anywhere I see y, I'm going to write the expression x minus 4. But be very careful. I have this negative in front of y. So I have to write a negative sign and then put x minus 4 in parentheses. Continue, minus 2x equals negative 5. Because this is equivalent to y. So now, hopefully you can see this. If you'd like to put a -1 in front, you can. But we now need to use the distributive property. And we need to distribute a -1 to each term in front. -1 times x is -x. -1 times -4 is +4. And then continue, minus 2x equals -5. Notice I did not distribute to anything else over here. Just what's inside the parentheses. All right, so now let's combine like terms. -x and -2x is -3x plus 4 equals -5. Let's subtract 4. -3x equals -9. Divided by -3, and I have x equals 3. Now, we had a lot of work for that problem, but there's definitely an easier equation to substitute x equal 3 into, and yes, it's the top one. So y equals 3 minus 4. Y equals -1. So the ordered pair should be 3, -1. Let's go check that on Desmo. 3, -1. Also note when you check on Desmo, typed equations, okay, not ones I'm rearranging, so just know that. That makes it easier and see if you do make any mistakes. All right, let's take a look at this one. Number 5, I have x isolated. So I'm going to substitute this in for x. My first equation, instead of writing x, I'm writing y plus 5 plus 2y equals -1. I don't need to put parentheses in this time because there's nothing, no number or coefficient or sign in front of that x. All right, so now let's combine terms. 3y plus 5 equals -1 minus 5. 3y equals -6. And then divide by 3, y equals -2. Hopefully you guys can see that we want to substitute into our second equation because it seems a little easier. And it's already set up for x equals. So we substitute -2 plus 5. And so x equals 3. Again, be careful when writing your order pair. It's 3 -2. And let's check on Desmos. Oops. All right. 3 -2. Hold on. Wait, 3 -1, x plus, and x equals y plus 5. So 11 and 12. 3 -2. There we are. All right. Oop, is the one I hand wrote in, where I want you to see we haven't had to do step 1 yet, okay? We have not had to rearrange anything. So I'm going to look at this equation or the system and I'm going to say, well, I don't have a variable isolated. So let's rearrange one of these equations. And if I look at them, the first equation seems to be easier to rearrange. This y has a coefficient of 1, so all I have to do is move that 6x to the other side somehow, and I'll have it rearranged. So let's go ahead, and I'm going to rewrite it over here. Y plus 6x equals 11. And if I can move this positive 6x to the other side, well, I can just subtract it. And I can get it in the slope-intercept form. Now I have a variable isolated. And now I'm going to go through the process and circle what y is equal to. And I'll be substituting into my second equation anywhere I see y. So let's have 3x plus 2. Instead of writing y, I need to use parentheses since there's a coefficient, equals -5. The first move is to distribute. Okay, 3x plus 2 times negative 6x is negative 12x. 2 times 11 is 22 equals negative 5. All right, I have 3x plus negative 12x. Combining like terms, negative 9x plus 22 equals negative 5. Let's go ahead and subtract 22. Don't forget that great wall. I have negative 9x equals negative 27. And last but not least, divide by negative 9, x equals 3. All right, when I go to substitute x value, we can put it back into, it says one of our typed equations. You could do one of the ones you rearranged if it was a simple rearrangement like this one, but it's always best to go back up into one of your typed equations or one of your given equations. So I have y equals 6 times, not y equals, I'm sorry, y plus 6x equals 11. Y plus 18 equals 11. I'll subtract 18 and I get y equals negative 7. So my solution, again, where my line should cross, should be 3, negative 7. Let's check these out. 3, negative 7. There's my solution. Now each of them, these are just the points which cross the lines cross. Now we have some word problems. All right, so we have an iPhone repairman charges $45 consultation fee plus $20 per hour of work. And another iPhone repairman charges a $30 consultation fee and $26 per hour. So we're going to define our variables here and then write our system of equations. We'll solve using substitution and answer, well, for what number of hours will the total charge be the same, which means equal, and what will that charge be? So first off, we have to look, well, we have to pay for this, for the iPhones to be repaired, and they're charging per hour, okay? They have an hourly rate. So we are going to define the X as the number of hours. And then, of course, we can talk about the Y in money. It's going to be a total cost. So let's talk about the system of equations. Let's look at the first iPhone repairman. Well, we have a total cost, and he is charging $20 an hour plus a $45 consultation fee. A consultation fee is just to look at the phone to figure out what's wrong with it. So I have $20 per hour plus that $45 consultation fee. Hopefully you can think about what the next equation is. The second iPhone repairman charges $26 an hour with a $30 consultation fee. And if this were 6-1, we would make a T-chart and graph it. But since we now know how to algebraically solve, we're going to solve using the substitution method because I have a variable isolated. So let's substitute 20x plus 45 in for y in the second equation. So 20x plus 45 equals, I'll finish this equation, 26x plus 30. Again, I'm going to look at which term with the variable has a lower coefficient. So I have 26 and 20. Well, let's move the 20x. Oh, not with the highlighter. I'll subtract it from both sides. And I now have 45 equals 6x plus 36. Now let's move this 36 because I want to isolate my x. So I have what? 6x equals, am I doing this right? 6x equals what? 45 minus 30, 36? No, 30. I thought I wrote something down wrong. I would have caught myself. My numbers aren't matching. Subtract 30. There we go. I should get 15. 15 equals 6x. And so I'll divide both sides by 6, so I get a decimal, 2.5. All right, that makes sense. We're talking about time, so 2.5 hours. That makes sense. So what will that charge be? So we're saying that at X, right? They're going to be equal. The two repairmen are equal at 2.5 hours. Well, what will that charge be? Let's go plug it into one of our equations and come up with what our Y is. I'll use the first one. It really doesn't matter which one you use. But I'm now going to plug in 2.5. So 20 times 2.5 plus 45. Okay, Y equals what? 50 plus 45, and Y equals 95. So my ordered pair is 2.5 comma 95. All right, so let's answer the question. Word problems usually require a word answer. So back up to how we define these. Remember, X is number of hours and Y is total cost. So the question is, for what number of hours will the total charge be the same? That's 2.5 hours. And what will that charge be? $95. So at 2.5 hours, both repair places charge $95. So think, if you know it's going to take 2.5 hours to repair your phone, does it matter which repair place you use or which iPhone repairman you use? It doesn't. We can go ahead, we can look at most, and we can keep scrolling out until we see a solution. There it is, 2.5 comma 95. And the Twin brothers, okay? They have their own bank accounts. We have Oliver, who has $800 in his account, but has decided to spend $20 each week on video games. His brother Chris has decided to start to save money in order to buy a new gaming system. Okay? Chris wants to save $10 a week and currently has $50 in his account. So the question, after how many weeks will they have the same amount of money? Well, let's come up with what our variables are. We're measuring time in, let's see, we're saving money $10 a week. We're spending money $10 a week. So our X is the number of weeks. All right, so clearly somebody's spending money, somebody's saving money. So Y is going to be the total money in account, right? In the bank account. Oliver's, think about it, he's spending money. His amount is going down. Chris's amount is going up because he's saving money. So let's come up with a system. All right, so we got Oliver. Let's do Oliver first. We're going to start with, well, how much is he actually spending? He's spending $20. So we're going to write that as negative 20 because the amount is going down by $20 every week from his account. And he currently has $800. That's Oliver's equation. Chris, on the other hand, is saving money. How much is he saving? $10 a week. And he currently has $50. So this is Chris's equation. The top one is Oliver. So close your eyes and picture what these lines should look like. Oliver's should be going down to the right, and Chris's should be going up to the right. But at some point, they're going to have the same amount of money. You can solve using substitution. Again, I have variables isolated. I love that. Let's circle what Y is equivalent to and then substitute it in the next equation. So I have negative 20x plus 800 equals, I'll finish my second equation. Now, I'm going to look to see which coefficient I should move. There are 4 ways to solve the problem at this point, but I want to try to get rid of negatives if I can. I'm comparing 10 and negative 20. Which number is actually the smallest? Negative 20 is. So let's move this negative 20x. I have to add it. I'm adding 20x. So now I have 800 equals, well, 10x plus 20x is 30x plus 50. Now it looks a little cleaner. I'll subtract 50. 750 equals 30x. And then I'll divide by 30. And I get that x equals 25. So x equals 25. Remember, x is the number of weeks. So something happens in 25 weeks. Oh, actually, it says, we're answering the question now. After how many weeks will they have the same amount of money? We've got our answer, 25 weeks. If we want to know how much that is, let's go ahead and substitute back into an equation. I'll use the second one this time because there's no negatives. So I have y equals 10x plus 50. I'll substitute 25 in for x. So y equals 10 times 25 plus 50. Y equals 250 plus 50. And y equals 300. So my ordered pair, my solution should be 25, 300. What does that mean in terms of the problem? So after 25 weeks, they both have $300 in their accounts. And then we can check it on Desmos and do 17 and 18. All right, click. Like, notice my green line is Oliver. He's spending the money. My blue line is, I believe, Chris, who is saving the money. And right here at 25, 300, they have the same amount. That is section 6.2, solving systems by substitution.